Yeah, just saying that something gets some pussy.
Ooh, baby, I like it raw. Yeah, baby, I like it raw.
Weed every day. Weed every day. Weed every day.
Yeah! What up, YouTube? What up? Jolioli coming at ya for a custom girl 420. Is this 18 over channel designed for cannabis patients and adults? Alright, in this one, we're gonna handle some fat energy transfers. Take it away.
Alright, so yeah, fat ones. We're talking all kinds of MGHs for that potential energy.
1/2 MV squared for that kinetic.
And even sometimes MV squared over R. But guess what? That's physics 1 stuff. You guys already failed that test. We're on to physics C. We got a new test to fail. So guess what? We're going to be taking work into factor in this because, you know what? A change in energy is equal to work.
Don't forget about power.
I think you're right. Alright, so we're going to go ahead and get into it.
But
catch you
first-
guys on the flip side.
We'd like to thank our sponsor, Supreme Dad. Alright, I'm gonna hand you over to Ryan. He's gonna show us what it's like spending his energy, kicking it in the streets of Lakeway. Take it away.
Fuck the police! Alright, so now that you guys saw a little bit of what it's like in doing my life in Lakeway, putting in work 24/7, I want you guys to know a little bit more about work and energy. So before we go more specifically into it, I'm going to give you guys some examples, not only using the actual problem that you guys will be looking at, but we're going to give some real world examples such as going downtown talking to people about what they do to work or what they do for their own work and how they spend their energy. But that'll be more in the director's cut, which we'll be releasing soon. So make sure if you like what you're seeing, subscribe to Supreme, and we'll make sure to show you what's good. Alright, so more so in the physical terms, I want you guys to remember that work equals delta KE, or a change in kinetic energy. And that's important because, you know, if I'm going to put in energy into something, like for example, this double cup, I took it off of the table, that's a change in kinetic energy. Took a sip, my body is then going to digest that. That's putting in work, you know what I'm saying? More to come. See you guys. Alright, so now that we just went over a brief overview of all of energies and physics, including calculus, we're going to go on and do the practice problem that you'll get, the practice free response problem. So we're going to start off, obviously, with part A.
And here we go.
Alright.
Alright, so what I'm going to try and do is I'm going to try and mimic super cram in this time, so I'm going to go super fast. Alright, so what we want to do first is find the speed of the box times 0. So speed of the box is derivative of distance, so that ends up equaling 1.5 t squared plus 2. So that's the speed, v equals speed. So we have to find out time equals t0, so speed of the box time equals t0, so we just want to plug in 0, so that is 2. Speed equals 2 meters per second squared. And that's done with part A.
Once we finish part A, we've got to move to part B. It's the only logical thing to do.
And this is where it gets really challenging.
We did not have to look up the answers for this, because we're actually the smartest kids in the class. We're going to Harvard.
Really smart.
We're really, actually the smartest, actually. So, what we need to do is find the kinetic energy of the box. Now, I for one forgot the kinetic energy formula. Ryan, could you please tell me it?
Kinetic energy?
Kinetic energy, yeah, it's when it's like moving. I'm blanking my mind. I know it's something like, is it P equals mv?
No, remember, kinetic energy is equal to mgh.
You little trickster. Kinetic energy is 1/2 mv squared. I know that.
What are you talking about?
See, out here in Tennessee, we got a saying. I don't know if you guys have it there in Texas, but we got one here in Tennessee. It goes a little something like this.
fool me once, shame on you. Fool me, can't get fooled again.
You know what? I'm sick and tired of your sass. You know, you want people to have sympathy because you're trying to do a problem with a broken hand?
Mm-hmm.
But guess what? I'm about to say it. Don't make me say it.
Say it.
I'm about to say it.
Say it then.
I don't care that you broke your elbow.
Box kinetic energy, as we know, equals 1/2 mv squared. So we know that. We know that. That's fact. Okay, so what we want to do, we want to find the kinetic energy. We have the mass. The mass is 100 kilograms. So 100 times 1/2, that's 50 kilograms. 50 kilograms times the velocity squared. So velocity is 1.5 t squared plus 2. Now what that ends up equaling is here. I got my cheat sheet down here. I don't want to do math. The math is pretty simple. It's just squaring this out because it's velocity squared, and it all ends up equaling 112.5 t to the 4th plus 300t squared plus 200. And that's what it ends up equaling, and that is basically the kinetic energy or the ox measured in joules. Alright, we're continuing our supergram. So we all know net force acting on an object, that is net force sigma F equals ma. We've all used this equation quite a few times to get us those extra few points on those free responses that we didn't know because we never knew free responses ever. It's pretty much a fact. So what we know is that m is 100 kilograms. We know that a is 3t. We take the derivative of velocity. The velocity is 1.5 t squared plus 2. The 2 goes away. 2 times 1.5, that's 3. 3t. So a times 3t, we get f equals 300t. That is it. In derivative of time. That's good. Perfect. Not derivative, in respect. My bad. Super grim. Alright, so we have that. Now we want to do is power. Power is P equals FV. That is a simple equation. Very easy. We take what we got earlier. So P equals 300t times what the velocity was, which is 1.5 t squared plus 2. Now I'm not going to do that math because math is gay and no one likes it. So what we do is we have that equal, and 450 equals t squared, t cubed, my bad, plus 600t. And that is what the answer is. The answer is that. So there's your answer for power. So power is that. Power mass. Alright, so what we want to do, calculate the net work done on the object in interval 0 seconds to 2 seconds. Alright, so work is basically changing kinetic energy. We all know that. So what we want to do, that's kinetic energy, the final minus initial. So the final, 2 seconds, we plug that in, that gives us 1/2, 100 times, this is the MVH, and 1/2 mv squared kinetic energy. So velocity at 2 seconds is 8. So 8 squared minus 1/2 velocity at 0 is 2 squared. You just plug the seconds into the velocity formula to get those two ones. And what we get is work ends up equaling 3,000 joules, and that is the end of your free response. You are now probably not going to ace the free responses on the physics exam because it's probably going to be about 80 times harder than this, but it's okay. Super good.